Last lesson of the year, 10-8, quadratic and exponential regression. I am excited for it because in some of your later math classes, man, do they use these equations a lot, but they never show where they come from, right? So I purposely designed this last lesson to be like, you know what? I want to show them how this quadratic and exponential regression stuff works. Because would you believe there is a lot of data collection in the real world, right? And they use that data collection to predict future events and things like that. So that's what we're going to do. That's called regression. It's like, hey, here's what the data looks like, right? Let's use it to predict some future stuff. So here, this table shows the population of Yolanda's hometown in thousands, where T is year since when? 2010. So what do you think about this right here, year 0? What year is it really? 2010. Cool. They say use the data in the applet and use the quadratic regression tool to find the equation. Well, let's go to Canvas, right? And if we click on data needed, it will have all 3 problems for us. So this is the data, so we don't have to do any typing in. But when it comes to the applets, we need to do 2 quantitative variables. So we'll choose the 2 quantitative variables guy. And the crappy part about that is you have to copy the x values first, and then the y values second. So we'll paste those bad boys in. These are years. And then this is the population in thousands. And then don't get too far ahead of me. I should have had this kind of prepared already, but I do not apologize for that. So you can hit begin analysis once you have it all in there. But would you believe if I asked you to describe that scatter plot as linear or nonlinear, what would your brain say to you right away? It is nonlinear. Does it look kind of like parabolic? That's a fancy word, like a parabola, you know, that opens down in that case. So definitely kind of looks like a parabola. So this is what happens in the real world. This is the population of her hometown, you know, starting in 2010. You can see it was going up, and all of a sudden it started to come back down. So if we scroll down, you know, the correlation coefficient, that's just that R value. That's not very strong at all because that's doing it on a linear scale. You know, don't care about that. The least squares regression line, we did that before. That's not going to work at all because this is not linear data. Are you with me on that? So if we scroll down even further, it says calculate an other regression model. We're going to calculate the other regression model. It's got a drop down of quadratic or exponential. I think this looks quadratic, you know, because it's going to make like a parabola in that case. So we have calculated the other regression model. And go look at that bad boy. How well does that parabola fit the data? Strong, moderate, or weak? That's pretty strong, right? You know, that's pretty good. The dots are really close to it. So if we scroll down to the equation of this bad boy, we'll put it into our little problem right here. So they say use the applet and the quadratic to find the equation. It was y equals, and then it's just kind of like a little crazy one right here. 22.962 plus 2.085x minus 0.213x squared. I think that's what it was. That's what I have written on paper. I'm going to go snip this out and put it into my deal so we're double checking on it. And yes. Silly thing is they don't write their equations in standard form. Even when it was a line, they did it backwards. They didn't do y equals mx plus b. They did b plus mx, you know. They do that here. I don't know why they want to do that here, but check it out. If you were looking for a, b, and c, are you down that a is the number in front of x squared? That's this guy. Is he positive or negative? So that's why the parabola opens down. B is the number in front of x. And c is your constant term. Are we kind of cool? They just do it backwards, you know, so watch out for that. Does the model fit the data well? What do you think, yes or no? Yes. Big fat yes. Estimate the town's population in 2024. So what would we have to do with that? Is 2024 a year or the population? That is a year. Should we put 2024 into this equation, or do we have to modify a little bit? What does X stand for, or T, I guess, stand for? Year since what? 2010. So what would we have to put in for X in this case? 14. Are you with me on that? So definitely a calculator day. Sorry, if you need to come get one, come get one. But let's put this guy into the calculator. And I'm still typing it in, minus 0.213 times 14 squared. Hey, before I even do all this, here's my question. Is 2024 very far off? Is it an extrapolation of this data? This would be what year right here, this 8. What year is this? 2018. So is 2024 super far off? I don't think it's that. It's kind of far off, but it's not super far off, right? So it should, like, kind of follow the data before I, like, hit equals. Shouldn't it just, like, kind of start going down further, right? You know what I mean? It should. You'd think so. So let's hit equals and see if that number makes sense. If I hit equals, did you get, like, this guy right here? Cool. So 10.404, right? You know, but homework might not accept that, even though that's what it is. 10.404, because isn't that population in what? Thousands. So I need to take that times 1,000. For those who are really good with decimals and stuff, taking something times 1,000 moves the decimal 3 places to the right. So wouldn't that be 10,404? Right? Are we cool with that? 10,404. And then here's the part where we got to go back and use our memories from previous chapter. That was 10,404. Use the model to find when the population peaked. So that's some chapter 9 stuff. Not when, like, it actually peaked with actual data. When they say use the model, that means use the equation. So what part of the equation is where it peaks at? What's that thing called? The? Starts with a B. That's called the what? The vertex. So we got ourselves a final exam coming up. Do you know how to find the vertex of a parabola? There's a little bitty formula when it's in standard form. Do you remember what that is? X equals opposite of B over 2 times A. So let's use these nasty decimals and realize, remember, it matters who A, B, and C is. So the opposite of B would be negative 2.085. And then 2 times A, I'm going to grab my calculator and do negative 0.213 times 2. You just got to make sure you get the right A value, you know, because some people use that C value because they wrote everything backwards. Negative 0.462. I think I may have wrote that wrong. 426. I said it wrong, wrote it right. So punch that in. Punch that in. 2.085 divided by 0.426. I didn't do any negatives because I know a negative divided by a negative is a positive. So this is what I got. I'm going to round that to 1 decimal place. About 4 point what? 4.9. Kind of get rid of that equal sign. And here's my question. Do I need to find the y value of the vertex, or is this the answer? We just found the x value of the vertex, which is for what? Years, right? What are they asking me to find? When or how much? Use the model to find when it peaked. So about 4.9 years after we started, which would be about what year? About 2000 and what? Almost. I'm not going to argue with you about 2015. Did it happen in 2015 or did it happen in 2014? It happened in 2014. When? The beginning of 2014, the middle of 2014, or at the end of 2014? Like probably the end, like 4.9. Probably in December-ish of 2014. So I'm going to put, you know, at the end of 2014. I don't know what homework's going to accept. I didn't get that detailed into it. I could totally see where maybe they say 2015 is the right answer, but true or false, it really didn't happen in 2015. It really happened in 2014. That's kind of a tricky one. How do you feel about the regression model, right? Putting it in the applet and letting it do all the calculations for us. So let's try a different one here. The table below shows the height in meters of an object that is thrown off the top of a building t seconds after it's thrown. Use the applet to do a quadratic regression of it. So let's do that again. Let's go back to the applet. I'm going to reset everything. And I got the data right here. So we'll do our time. I'm so nice to type all this into a spreadsheet for us. This is the time in seconds. And then the other thing is the height of that data. And I think meters, is that right? 2 quantitative variables. Is it measured in meters? Cool. And begin the analysis. I definitely may have typed this in wrong. Did I type this in wrong? Let's see here. No, I think we're good, right? Is this what yours looks like? Okay. Cool. So let's do the quadratic regression on it. So scroll on down, calculate other regression model. Do you see that it is curved and not linear, right? It's very nonlinear, right? So there's 2 types that we'll do today, either quadratic or exponential. Remember, exponential growth starts real low and then gets real high, you know, so let's calculate this bad boy. Boom. Look at those residuals, by the way, very close to 0. The residual, I know it was kind of new last time, is like how far off they are from the line, you know? Check it out. How far off are those bad boys from the predicted curve? How far off? Not much at all. Barely anything. I did dive deeper into it when I was making my practice answer key, and they are off a little bit, but it's like very, very tiny amounts of what they are off. So would you believe that this is a very good model for this situation right here? So I'm going to snip this guy out and put him into our page if I could find him, and let's go answering those questions. So write the regression equation. We got him right here. 69 plus 30.9x minus 4.9x squared. They say round to 1 decimal place. It came out nice to 1 decimal place, so don't have to do much there. 69 plus 30.9x minus 4.9x squared. Using your quadratic regression, how high will the object be 2.8 seconds after it is thrown? Help. 2.8 seconds. Is that an x value or a y value? Or in this formula, a t value or an h value? Let's just do x's and y's for simplicity. What do you think, x or y? That's an x value, right? So we'll go into our equation, and we will punch that in. Clear all this out. 69 plus 30.9 times. Is it 2.8? Is that the number we're trying to do? Yep, thank you. Minus 4.9 times 2.8 squared. That's probably the biggest mistake when you're punching stuff in, forgetting to square that guy. You know, it's like, oh, God, I forgot to square it. So are we cool with that? So let's see. It should be between these two, right? You know, isn't it 2.8 between 2.5 and 3? So it should be between 115 and 117-ish. You know, so did we get something very, very close to that? So they say round to 3 decimal places. It came out to 3 decimal places. So 117.104 meters, baby. But now there is an algebraic way to do part C, and there is a graphing calculator way to do part C. It says use your quadratic regression and the Desmos graphing calculator. How long will it take? How long will it take? Would you believe we don't know t then when they're asking us to find the t for the object to reach 17 meters, right? So if we go to the internet and open a new window and just type in Desmos graphing, and then it'll start bringing up the graphing calculator. We did this once before. Desmos graphing calculator is what we're Googling. We did this once before. Our job is to just type in this equation, y equals 69 plus 30.9x minus 4.9x. And then to square it, you have to use the caret key on the number 6, you know, the little thing that's pointing up. So get up there and square that. Bad thing about this guy is it doesn't pick a good window. Like, would you believe it's graphing this guy for us? When you did it for all the Newton's Law stuff, I already found the windows for you. But it's pretty simple. You can just pinch to zoom to shrink a little bit. You know, pinch to shrink. And then what I will do is spread the x-axis out a little bit, maybe if I can. But I'm not too worried about that. You know, if you just pinch it a little bit, you can see this guy. They ask us, how long will it take for this to hit 117, excuse me, not 117, but just 17 meters. Isn't that a height, right? Is that an x value or a y value? So down below, click another line to start, and we'll type y equals 17. Isn't that totally what we want to know, is when this thing hits 17? And because this is such a wild window that I have this graphed in, I'm going to zoom in a little closer to what I got with pinching to zoom. And can you tell, it did happen twice, right? It happened right here, and it happened right here. I just want to know where those guys intersect at. Well, look at this one. It happened in negative time, right? So we're going to throw that out. That's called an extraneous answer. How long did it take for that thing to hit 17 feet? They say round to 3 decimal places, so about 7.687, right? Are we okay with that? So I just graphed that on the Desmos graphing calculator. When you get further along in your math life, we will teach you how to use the TI-84, because you can use that on the ACT, because, not 17, but 7, sorry. Because, man, wouldn't that be awesome if you could use Desmos, like, on the ACT, but they're not letting that happen yet because you need the internet. There are special apps that can allow that to happen with phones. I don't think the ACT people are too keen on kids having their phone out during the ACT, though, right? So you can use that graphic calculator, and in Honors Algebra 2, they will teach you how to do that on that calculator. But I just figured I didn't want to do the quadratic formula on that. That's what we would have had to do, is the quadratic formula. Are you guys okay with that? All right. Nice. One more, man. One more. And then we'll do our cool activity for today. It says the table below shows the value of an investment n years after 2000. I know I don't want to bore us too much because I want to get to our activity, but are we okay with what investing money is? Like, you let it sit there and it'll grow, you know, all that stuff. So let's put it into the applets. So we're going back here. I'm going to reset everything, and we will copy this data. Notice that it went 1 year, 3 years, 7 years, 12 years, 14 years. So it's just like kind of not all in order or anything. It's just wild, random years later. And then this is how much it was here. It's like a race inside of those spreadsheets when we're trying to all copy the same data. So this is years, and this is the amount of the investment. And I shall hit begin. Uh-oh, I did not copy things right. So did that happen to you guys also? No, I missed the 19 is what I did. Sorry. Okay, Control C. So I'll just put 19 there. How's that sound? How about now? Does it look like this? What do you think? What does that look like to you? Linear or non-linear? It's very linear looking, right? You know, but it also could be non-linear because you see it kind of like it's got a little curve to it right here. You know, just a little bit of a curve. Well, the cool thing is if I do what they tell me to, it'll be all right. So they want us to calculate an exponential guy in this one, and let's see how well it fits. What do you think? Does that fit the data pretty good? I'm going to go click the linear one just for the sake of it, and like, what do you think? They're both pretty darn good. Would you agree with that? They're both pretty good, but people knowing investment strategies understand that that's going to be like the exponential. So I'm going to hit that, and it'll do it. So nice. Let's put that formula in. This is our exponential guy, which has been a long, long time since we have talked about exponential equations in here. So let's see here. That's going to be y equals They say to do some special rounding. Round the A value to the nearest whole number, round the B value to 3 decimal places. So let me see if I can refresh your memory. B, which one do you think that stands for? Just like a coefficient or the base? What do you think? What do you think B stands for? Base. Out of these guys, which one of these numbers is the base? The 4,000 some guy or the number with the exponent on him? Which one do you think is the base? This guy, right? So they want him rounded how? 3 decimal places? Cool. But how about this other guy? What do they say round the A value to? That's the A value to the nearest whole number. So 4,922. 4,922. I'm going to use parentheses, 1.049 to the x, right? To the x. That didn't show up very well because I wrote it too high. So let's put it up here, to the x. That is an exponential growth because that base is bigger than 1. These are some final questions coming your way. Exponential growth. Why is it even exponential in the first place? Where's the x? Down at the normal level or up in the exponents? Exponent. That's why that's exponential. So based on this, what is the percent increase per year? That's a tricky question because we haven't talked about that in a long time. Is this base bigger than 1 or not bigger than 1? Bigger than 1. How much bigger than 1? Would you believe it is bigger than 1 by 0.049? Like if I got rid of the 1, isn't that what it's like bigger than 1 at? So let's change that to a percent. Move that decimal 2 places to the right, and what would you get on that bad boy? 4.9% increase. That's like the interest rate that this account is getting, 4.9% interest. Based on this regression model, what is the value of this investment in the year 2000? Well, N stands for years after 2000. Are you with me? So how many years after 2000 has 2000 been? 0, right? Don't we need to put 0 in for x into that situation? I can do that without a calculator. What's 1.049 to the 0th power? Is it 0 or is it 1? Anything to the 0th power is 1. 1 times 4,922 is 4,922. So there's a little bit of like fallen into some review that this is your starting value also. You remember that also called as principal, right? You know that is your principal amount. So good stuff there. Based on your regression model, what value will this investment be in 2020, right? So what do we got to do here? Put what number in for x? Put 20 in for x. So we will go and do, we'll use our formula, not this one, right? So we'll use the one that we rounded off. Does that make sense? So we'll use 4,922 times 1.049 to the 20th. Yeah, when they had us do the rounding, it was kind of for a reason, so you didn't have to type all those decimals over and over and over again, right? So, and about how much? Since this is money, they said, you know, we'd either go to 2 decimal places to the nearest dollar, right? That's kind of how we talk in money. So they said to the nearest dollar. So 12,000 what? $813 dollar bills, y'all. Not bad, right? We started with $4,900, and 20 years later we got 12,000. So that's it. On the back side, there is an activity, but you must be present to do this activity. It is very, very challenging to do all by yourself because you don't have the materials. So let us know if you have any questions, and have a good one.